So if you're watching this for the first time at home, please make sure you pause because I want to go through this video kind of quickly. Let's begin by asking the question, what is a radical? And the answer to that is a radical is a square root. And of course, we should all know that a square root looks like this, right? Okay. So, and most of us should also know that the square root of 9 is what? 3. Okay, if you don't know, that's okay. We're going to figure that out in a little while. But before we move on, let's check this out. A square root is the opposite of a square. Okay? So, kind of like when we would, like if I ask you math operations, what's the opposite of multiplying? Dividing. What's the opposite of adding 3? Subtracting 3, right? So a square root is the opposite of a square. So this is not too important right now, but it will be very important in future sections. When I say the square root of x squared, the square root and the square, they undo themselves. All right? They're opposites. So they kind of cancel each other out, and the answer is just x, right? So if I had something like the square root of 3 squared, the square root and the square, they undo themselves. So what's the answer right there? 3. Okay. So this truth is going to be very important in future sections, not that important in this section. Okay. But let's just keep that in mind, that a square root is the opposite of a square. So we will be simplifying radicals. And what we need to first understand are perfect square numbers. So what is a perfect square number? 4 is a perfect square number. As a matter of fact, let me show you a perfect square number list and see if you guys could catch on. Book, write down perfect square number list and then start writing these numbers as they appear and let me know if you understand what the next number is. So the first perfect square number is 1. The next one is what? 4. The next one is not 8, it's 9. And the next one is 16. All right, some of us are catching on. The next one? 25, and then after that, 36, after that, 49, after that, 64, after that, 81, after that, 100. Now, those of us that caught on, we already know what's going on. Those of us that haven't, you're probably thinking, what the heck, where are these numbers coming from? So here's a perfect square number list from 1 to 144, and we all need to get familiar with this list. Now, you don't have to memorize it, because you could easily just write this list. Now, how do we write it? It's simple. All you got to do is this. Think, what is 1 to the second power? That's just 1. What is 2 to the second power? That's just 4. What's 3 times 3? It's 9. What's 4 times 4? It's 16. So this list, you could easily just write it on your paper. You don't have to have it memorized. You can just go through the numbers. 1 squared is 1, 2 squared is 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12. The next one would be 169 because 13 times 13 is 169. But of course, this list goes on forever. Now, the reason why I want you to get comfortable with this perfect square number list is because you're going to be able to simplify radicals today, and this list makes it a lot easier to do. This fact right here is very important, that the square root of a perfect square number, that's these numbers up here, is a perfect answer. Now, what do I mean by that? Let's look at these examples right here. What's the square root of 4? 2. You see, it's a perfect answer. What's the square root of 9? 3. 3, perfect answer. Square root of 36? 6. 6, perfect answer. Right? Square root of 64? 7. 8. Right? Who's that? The square root of 121? 11. 11. See, perfect answer. So the square root of any of these is a nice, beautiful, perfect answer. So we love perfect square numbers. We love taking the square root of a perfect square number. Why? Because you get a nice, beautiful, perfect answer, right? Just easily. The square root of 64 is 8. Square root of 121 is 11. Square root of 144 is 12. The square root of 4 is 2. The square root of 25 is 5. So the square root of a perfect square number is a nice, perfect answer, okay? Now, so if I did say, what's the square root of 20? That is not a nice, perfect answer. As a matter of fact, so here's the calculator, and I actually did the square root of 20. By the way, if you're wondering where the square root button is, here's the x squared button, and right there is a little square root symbol, right there, square root symbol. And in order for you to get the square root, you have to hit the second button. So you go second, and then hit that, and that'll give you the square root symbol that we have above. That'll pop this up right here, and it'll have an opening of a parenthesis, and you type in 20 if you want to do the square root of 20. Just make sure you close parentheses, hit enter, and it'll give you this crazy decimal that continues forever, that has no pattern. And if you remember that, back when we did classification of numbers, this is what we call an irrational number, right? It's a crazy decimal, irrational number. You guys remember that? Yeah. Okay, so I'm not going to ask you for a decimal number. I'm going to ask you to simplify the square root of 20, okay? So right here, it's obviously not a perfect square number. Now, we want perfect square numbers. Why? Because perfect square numbers give you perfect answers. Square root of 9.3, square root of 36.6, square root of 20, not a perfect answer. So I want a perfect square number in here. So when you're taking the square root of a non-perfect square number, you must break it down with multiplication to obtain a perfect square number, okay? So 20 is not a perfect square number. It would be totally pointless for me to rewrite it as 2 times 10 because 2 is not a perfect square. It's not up here on the perfect square number list. And 10 is not a perfect square. So what would be a good idea to break down 20 to? 5 times 4, and it's even better to write it like this, 4 times 5. You always want your perfect square number first. Once again, you want a perfect square number inside the square root. So if you don't have one, let's rewrite it with multiplication to get a perfect square number. So the square root of 20 becomes the square root of 4 times 5. Okay? Now, at this point, we're going to split the root. Now, we haven't really even seen the key concept here. Let me show you the key concept. Here's the key concept. It says that if you have the square root of a number times a number, you could actually take this square root and split them to each of the numbers that you're multiplying and just multiply them. Okay? So like if you had the square root of 3 times 4, you could split them and it'll be the square root of 3 times the square root of 4. Or the square root of 25 times 7, you could do the square root of 25 times the square root of 7. Okay, so it says if you're multiplying terms with a radical, within a radical, you can split the square root to each of the terms. That's the key concept. Now let's go back to the concept we just wrote down in our notes. Here it is. When you're taking the square root of a non-perfect square number, you must break it down with multiplication to obtain a perfect square number. So we did start with the square root of 20, and we said that 20 could be rewritten to what? 4 times 5. Now, why do I want 4 times 5 and not 2 times 10? 2 is not a perfect square. 10 is not a perfect square. 4 is a perfect square number. Yay? So that, again, you don't have a perfect square number. If you rewrite it with multiplication, now you could get a perfect square number. That way, when you do this part up here of splitting the root, check it out. Split the root to each of those. Now you could actually do the square root of 4. What's the square root of 4? 2. And what's the square root of 5? You can't do it. So you just leave it. So the square root of 20 simplified is really 2 square root of 5. Make sense? That's it? That's it. That's the simplified form. Now, it's kind of like simplifying is just doing any math possible, right? So the square root of 20, you could actually break it down to 4 times 5. Again, square root of 20, it's not a perfect square number. You break it down with multiplication so you could get a perfect square number. Now that doesn't always work. Like you might have, like let's say I had the square root of 26 and I told you to simplify it. And you're thinking, okay, 26 is not a perfect square number. It'd be easy if it were the square root of 25. The answer would be 5, but it's 26. Now, if I ask you to simplify it, could you actually break it down with multiplication to get a perfect square number? No, because 4 times what gives you 26? It doesn't work. 9 times what gives you 26? It doesn't work. 16 times what gives you 26? It doesn't work. So if you think about the perfect square numbers, and if you forgot them, just write them on your paper. 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, and you could write the list, right? Now, none of these perfect square numbers could be used to break down 26. Now you might think, oh, I could break down 26. I could rewrite it as 2 times 13. But is 2 a perfect square number? Is 13 a perfect square number? No. So if I ask you to simplify, then you just say it's already simplified. So sometimes you can't even simplify them. It's like saying, go ahead and do x plus 7. What's x plus 7? It's x plus 7. You can't do anything. It's already simplified, right? So sometimes I'll give you radicals and I'll ask you to simplify them and they're already simplified. The square root of 13, you can't do anything to that. The square root of 71, you can't do anything with that. The square root of 77, can't do anything with that. Let's actually look at some that we can break down with multiplication to get a perfect square number. Let's write these examples down. If you're at home watching this for the first time, hit pause, copy this down, and try to do them. If this were a 9 right here, right? What's the square root of 9? 3. That'd be done if it were a 9. But you see, it's not a perfect square number. Now, again, it's a good idea to write a perfect square number list to help you out when you simplify. So I wrote down the perfect square number list up there, and 8 is not up there. So I need to break it down. What times what is 8? 4 times 2. Now, if you say 2 times 4, it's better to write the perfect square number first. So let's write it as 4 times 2. And of course, it's the square root of it. So the above original, the square root of 8, is the same thing as the square root of 4 times 2. Now, the rule says, the key concept says you could split the root. So let's do that. Let's split the root to the square root of 4 and the square root of 2. And of course, the whole purpose of rewriting 8 to 4 times 2 is so we could have a perfect square number, so we could actually do the square root of that perfect square number. What's the square root of 4? 2. Okay? So, the square root of 2, you can't do it. It's already simplified. Just bring it down. And that's your final answer, 2 square root of 2. So once again, if you do not have a perfect square number, you want to break it down with multiplication so you could get a perfect square number. So, what would be good to break down 20 to?
4 times 5.
4 times 5. 2 times 10 would be horrible because 2 is not a perfect square, 10 is not a perfect square. But 4 times 5, like you guys are saying, that's the key right there. So let's go 4 times 5. That way we could split the root. And then the square root of 4 is what? 2. No more square roots. Just a nice, beautiful, natural number 2. And the square root of 5, you just bring it down. Number 3, the square root of 12. Would it be smart to break down to 6 times 2? No. Heck no. 4 times 3. You want a perfect square number, and 4 is a perfect square number, so I'm going to break it down to 4 times 3, and I'm going to split the roots. The square root of 4 is the nice natural number 2, and the square root of 3 can't do anything with that, so you just bring it down, and that's your simplified answer for number 3. Okay? Let's look at number 4. Now, number 4 is interesting. Sorry. Now, what could I break 32 down to?
4 times 8.
4 times 8. So check this out. If I go 4 times 8, and then I split the root, I'll have the square root of 4 times the square root of 8, right? But what is the square root of 4?
2.
The square root of 4 is really 2, and then you bring down the square root of 8. But the square root of 8, you could still break it down to get a perfect square number. Right? 8's not a perfect square number, but you could break it down with 4 again and say, okay, I have the 2 on the outside, and now on the inside I have a 4 times 2, right? And then I could split the root again to the square root of 4 and the square root of 2, and I could bring down that 2 that's in the front. And then the square root of 4 is really 2, and of course you still have the square root of 2, and you still have the 2 in the front that you need to multiply. Which means that the final answer is 4 square root of 2. Ta-da!
I'm confused.
Ask me if there's an easier way. There's an easier way. Okay. Check it out. All you got to do is take a couple of seconds and look for the biggest perfect square number that you could use. See, the problem was this. We saw 4 times 8 is 32. That's great. But look, a couple more seconds. How about 9? 9 times something give you 32? 9 times 3 is 27. Okay, 9 doesn't work. But 16 times 2 gives you 32. So if you use the highest perfect square number, check this out. We said 16 times 2. And what is the square root of 16? 4. What's the square root of 2? You just bring it down. Same answer. Just done in 2 seconds instead of 1 minute. Way easier. So what's the moral of the story here? Use the highest perfect square number possible. Use the highest perfect square number possible. So I actually wrote it down right here in the notes. You guys should write it down also. Always try and use the biggest perfect square number possible when simplifying radicals. So let me actually write my perfect square number list right up here so we could use it when we're simplifying. And we're going to use the biggest perfect square number possible. So let's take a look at the number 128. That's not a perfect square number. If it were 144, the answer would be 12. If it were 121, the answer would be 11. But it's 128, it's not up here. So if you see that it could be broken down with a perfect square number, like 4 will work. On a calculator, 128 divided by 4 is 32. So 4 times 32 could be used, but that's not the best option. The best option is to use the biggest perfect square number possible. So 128, let's look at bigger numbers like 100. Obviously 100 doesn't work. 81 times 2 is 162. That's too big. How about 64? 64 times something give you 128? 64 times 2. So that's what we do. 64 times 2, and then split the root, and what will our answer be? What's the square root of 64? 8. What's the square root of 2? It's just the square root of 2. So that's your simplified answer. So a good question, can't I continue breaking down the 8? You see, it's not the square root of 8, it's just 8. The square root of 64 is just the nice natural number 8. You're not going to do anything with 8. Now, but the square root of 2, you can also not do anything with that. So that's your final simplified answer. Let's look at number 2, 48. I mean, yeah, the first thing that pops up in my head is 4 times 12, right? 4 times 12, because 4 is a perfect square number. Now, you could do that, but it's going to be a longer road to the same place. Okay, what's the better option? What's a higher perfect square number?
16.
16. 16 times what?
3.
16 times 3. Now, if you're thinking 24 times 2, 24 is not up here as a perfect square number. 2 is not up here. So, I mean, even though you could rewrite it as 24 times 2, it's not going to help you. So you want to look at perfect square numbers, and 16 times 3 is the best option. Now, 16 times 3, when you split it, it'll give you the square root of 16, which is 4, and the square root of 3 stays the square root of 3. Let's take a look at number 3, 108. Again, let's go for the highest perfect square numbers. Like on a calculator, I could figure out 4 times something gives me 108. Let's go for a high perfect square number like 64 times 2. No, that's not 108. 49 times 2 is, no, that's not 108. Times 3 is too big. 36 times 2 is 72, but times 3 on a calculator, 36 times 3 is 108. Are you with me? Yeah. So 36 times 3. And of course, when we split the root, the square root of 36 is 6. And the square root of 3 will stay the square root of 3. And that's your answer. Simplified answer, that is. Again, I could have done these numbers with 4. I could have done 4 times 12, but it would require more work. Using the highest, the biggest perfect square number, that's the quickest route. Not only that, guys, we also have, you may have a number on the outside of the radical when simplifying, okay? So like number 1 right here, we have 3 square root of 4. Now what does that mean, 3 square root of 4? That means 3 times the square root of 4. Now, what is the square root of 4? 2. So you really have 3 times 2. What's the answer? 6. That's it. Cool? Now, over here on number 2, we have 4 times the square root of 12. So always look at your radical like we did over here. The radical square root of 4, I could actually do that. I get 2. And then I worry about 3 times 2, right? Over here, same thing. The square root of 12. Is it a nice, beautiful answer? No. But could I simplify it? Yes. The square root of 12 could be broken down with multiplication to what? What's the square root of 12 broken down with multiplication? 4 times 3. 6 times 2 is no good, but 4 is a perfect square number. So when you split the root, you'll get the square root of 4. Now let's not forget about the outside 4. See this guy? I just wrote it down here. And the 12, I broke it down to 4 times 3. And now what is the square root of 4? 2. So what we really have is the outside 4. That's a nice, beautiful number 4. And then we have the square root of 4, which is actually the nice, beautiful number 2. And of course, we are multiplying between them. And let's not forget to bring down the square root of 3. So what's the only thing I could actually do? I have 4 times 2 times the square root of 3. So what could I do? I can multiply 4 times 2. And that'll give me what? 8 square root of 3 as my final answer. Make sense? So again, on number 3, you have a number that's being multiplied with a radical. Let's first focus in on the radical. Could I simplify it? The square root of 18 breaks down to what? 3 times 6. However, is 3 a perfect square number? No. Is 6 a perfect square number? No. So it's not good to just break it down. You want to use a perfect square number, and 9, like you said, 9 is a perfect square number. So 9 times 2. So let's first just bring down the 5, and then I'm going to rewrite 18 as 9 times 2, and I'm going to split the root to each of those. So what I really have is 5 times the square root of 9 times the square root of 2. Now, what is the square root of 9? This right here, what is that? 3. So I really have 5 times what? Times 3, and then times the square root of 2. Now, what is 5 times 3? That's 15, right? This is 15. Square root of 2 is your final simplified answer. Now, this rule that we learned about splitting the root, it could also be used backwards. You could have separate radicals, and you could put them together, multiply the numbers, and put one square root over them. Let me show you some examples. Please copy those down. If you're at home, hit pause because I'm going to jump right into it. So, I want to show you how to use the rule backwards, but let's pretend that we don't want to use the rule backwards. Check this out. I wrote example 1 up here in red, and let's actually zoom in on this first example. And if I wanted to do this and I asked you to simplify, you know you can't do anything with the square root of 2, but you could do something with the square root of 8. What do you break that down to? 4 times 2. So you go square root of 4, square root of 2, and you're going to take this guy and just bring it down right in front, right? Now, what is the square root of 4? 2. It's 2. So this guy is really just the number 2, and you have the square root of 2 here, and you have the square root of 2 over here, and we're going to rearrange them. I'm just going to switch the order. That way it'll be 2 square root of 2 times the square root of 2, right? Now, at this point, I have this times itself. So you could say 2 times the square root of 2 squared. But the square root and the square eliminate themselves, yes? Which means that you really have 2 times 2, because the square root and the square eliminate themselves, so you just get a 2. And 2 times 2 is what? 4. Now, you see all that work?
But where did you get the parentheses from?
I wrote them. I said the square root of 2 times square root of 2 is the square root of 2, but squared. Because if you have like 3 times 3, it's really 3 squared. If you have x times x, it's really x squared. Now, let's not get caught up on this, because I want to show you a better method than doing that. The better method is to go backwards. The rule can be used backwards. Okay, now what do I mean by that? I could take 2 separate roots and put both numbers inside one single root. So look at number 1, which we just did up here with all that confusing work. Let's take a look at number 1 right here. I could put them together under one single root. That's going to be the square root of 2 times 8. What is 2 times 8?
16.
That's really the square root of 16. What's the square root of 16?
4.
You see that? ¿Qué te dije? You see?
That's what I did the first time, and then you were doing all the work, and I thought I got it wrong.
Okay, so the reason why I went the long path is so you could appreciate the rule backward, the shortcut. Okay? So you could put them together when it helps you, like number 2. Now, I could rewrite this as 4 times 3 and do all that work, or I could realize, hey, if I put these together underneath one square root, what'll it be?
36.
It'll be the square root of 36. And what's the square root of 36? 6. Done. So the answer is 6. Amazing, right? Now let's say you're bored on Saturday. Then yeah, go for it. Then go for it. Simplify the square root of 12. Rewrite everything. Right? There's many roads to the same place. Let's look at number 3 right here. Now, what is the square root of 7 times the square root of 7? You could put them together and you'll get the square root of 49. And what is the square root of 49? The answer is 7. Yeah, you put them together, multiply them, and then do the simplified square root. Whoa, what happened? Number 4. Ladies and gentlemen, right here, there's different methods of doing it. I could put them together. What's 6 times 2?
12.
So I could do the square root of 12, but then I got to think. 12 is not a perfect square number. What could I break it down to? 4 times 3. And then you get your final answer, 2 square root of 3. Of course, you want your perfect square number first. Does that make sense?
What if you don't do that in a test on your phone?
So let's try the next one.
Wait, are we doing this because then
Let's take a look at number 5. Now the rule backwards says if you have separate square roots, you could multiply them together and put them underneath one square root. Now check this out, guys. We do need to recognize that 2 square root of 3 is really 2 times the square root of 3. Then you have times 3 square root of 2, which is really 3 times square root of 2 times. It's all multiplication, so you could switch things around. So let me put the nice numbers all together. I want to put 2 times 3 times 4 all together. And then I'm going to put the square root of 3 times the square root of 2 times the square root of 6. Now this rule backwards says I could put them together. I could put the 3, the 2, and the 6 all together underneath one square root. So on the outside, I have 2 times 3, which is 6. 6 times 4, which is 24. That's the nice number 24. And on the inside of the root, I could put 3 times 2 times 6. Now what is 3 times 2 times 6? 36. So my new problem is really 24 times the square root of 36. And the square root of 36 is what? 6. So I really have 24 times 6. And 24 times 6 on a calculator is 144. So that's how you would do number 5. Yeah, it's a long process, but that's I think the best way to do it. Number 6, we're actually going to stop right here because there's nothing this confusing on the homework.